Welcome. My name is Bill Martin. I'm president of Martin Business Consulting Incorporated, and I'll welcome you to this brief review of the intent of SPC, or Statistical Process Control, for the efficient process control of manufacturing and business processes. The following brief demonstration of a process control utilizes an SPC chart. This fictitious process in question is a machining operation that is generating a locator pad. This pad must be to a very exact tolerance, as it will be used in a later process step as a datum to create other product features. This presentation is demo only and does not define or imply your requirements for manufacturing process control. Each application of Statistical Process Control, or SPC, must be independently defined and developed by the organization. This top chart on this slide is a record of each part manufactured. As you proceed through this presentation, each of the representative 620 manufactured parts are measured and recorded on this top portion of this chart. The bordered chart is an SPC control chart for average and range, commonly referred to as an X bar and R chart. The top portion of the SPC chart records the average for each subgroup. In this case, we are measuring 5 parts for each subgroup and recording the average on this upper section. These two dashed lines indicate the control limits for the subgroup averages that will be plotted on this chart. This lower portion of the SPC chart records a subgroup range. The plotted point are a representation of the amount of variation found within the subgroup of the 5 parts that were measured. This dashed line indicates the control limit for the range values of each subgroup. We've now started the manufacturing process and we've measured the first 5 parts. These 5 points represent the height dimension of the first 5 parts produced. This is a subgroup of 5. The X indicates the average dimension of the 5 parts in the first subgroup, and this is recorded on the upper portion of the X bar and R chart. The R indicates the range of measurements in the first subgroup, the highest value minus the lowest value, and this is recorded on the range portion of the SPC chart. As you can see, both the X and the R are within the control limits for this first subgroup. Being in control, with this indication we are now able to continue the manufacturing process by running additional parts without further inspection at this time. 200 parts are run, and since this process is in control and stable, we're able to run these 200 parts without additional inspection activities. After the completion of the 200 parts, it is now time for the second subgroup, and the 5 blue dots are the plotted dimensions of the second subgroup of 5 parts, measuring the locator pad height once again. Again, the X indicates the average dimension of these 5 parts of the second subgroup. The line connects it to the X from the first subgroup average, and thus begins this trend chart of averages. The R indicates the range of measurements in the second subgroup. Since this R is above the upper control limit, and that is due because of the large amount of variation within the 5 parts that were measured, as is indicated by the double red arrow above. So before we can continue producing additional parts, we must investigate the special cause of variation. Our investigation shows a maintenance problem with hydraulic clamping pressure. The problem caused a variation in clamp pressure, leading to the excessive variation of this subgroup. With the problem now corrected by the maintenance organization, we are now able to continue processing additional parts. Again, having taken the corrective action on the special cause of variation, the process is again in control and stable. We're now able to run the next 200 parts without additional inspection. The 5 green dots are the plotted dimensions of the third subgroup average, measuring, again, the height of the locator pad. The X represents the plotted average of the third subgroup. Once again, the R represents the range of the third subgroup. And now we notice that the average, indicated by the X, is below the lower control limit. This is due to the top chart showing that the process has drifted to the low side. This drift has caused the SPC chart to indicate an out-of-control condition for the process average. Again, before we can continue processing parts, we must investigate the cause of this out-of-control condition for the process average. Our investigation shows an adjustment problem with a locator that has worked its way loose. The maintenance department has made the repair. Processing can now continue for an additional 200 parts. Having taken the corrective action on this special cause variation, the process is again in control and stable. We are now able to run the next 200 parts without additional inspection. The 5 brown dots are the plotted dimensions of the fourth subgroup, again measuring the locator pad height. With the plotting of the average and range of the last subgroup, we're able to determine that at this time the process continues to run in a stable and capable manner, as both are within the control limits. No further action is required at this time. This red dashed line represents the upper specification limit from the design print for this locator pad height. This red dashed line represents the lower specification limit for the locator pad height as found on the print. We only checked 20 parts out of 6 hours production, but all of those parts are within print specification. As you can see, the second subgroup, though the variation was excessive within the subgroup, that caused an out-of-control condition for subgroup number 2 on the range portion. We were able to react and correct the process before we had parts that were out of specification. Starting up after the second subgroup, the process slowly began to drift to the low side of the tolerance because of the maladjusted locator component. But again, we were able to measure the third subgroup, identify the special cause variation because the average of the third subgroup was below the lower control limit. We were able to respond before we actually had parts, again, that were out of specification. Making the corrections, we were able to complete the shift with all parts within specification. A very successful production run. The SPC chart allowed for effective and efficient control of the process. The efficiency of checking 20 parts out of the 620 parts produced and having all parts within specification has turned out to be a very cost-effective approach to process control. Congratulations to this production team. Thank you, and my sincere desire is that everyone benefits from this brief presentation in your understanding of the intent of SPC and how statistical process control can be utilized for early detection of process variation, making process adjustments, corrections, and repairs prior to having parts out of specifications. If you have any additional questions, contact me, Bill Martin, President, Martin Business Consulting Incorporated, at the email or the phone number identified on this slide. Again, thank you very much.